Hello. Well, so today we are talking about Pac-Man, which is a game from the early 80s and obviously one of the definitive arcade games. And something that probably a lot of people don't know, because most people don't spend their time compulsively playing video games, is that Pac-Man comes to a dead halt at level 255. So we are going to be talking today about the number 255.
Have you ever got to level 255?
No, Pac-Man's not my game, so I've made it to level 20 or 30, and then normally I need a Wii or something. And so I guess what this relates to is the way computers and microchips were built back in the early 80s. They were all just 8-bit processors. And what that meant was that they had 8 lines inside the processor for carrying the numbers on, which limited what the computers could do. Today, I'm going to show you how and why that limits what computers can do. Well, I'm going to start by showing you how computers count. Computers count in a thing called binary, which basically means they have on and off. So let's start with off. And we're going to pretend that this is a computer with 4 bits. And for the number 0, each one of those lines is set to 0. So all I'm going to do is start adding numbers to the rightmost column. I'm going to add a 1 to the 0, and then the rest of the numbers stay the same. And that is the number 1. So now we're going to aim to add another 1 to go to the number 2. So when I add a 1 to this column, in binary, there's no more space in this column. Okay? So what we're going to have to do now is carry 1 into the next column, exactly the same as adding 1 to 9 would be in decimals. So I add 1, that becomes a 0, and we carry 1 into the next column. And the rest of the columns stay the same. And that is the number 2. So for number 3, what we're going to do is add 1 to the 2. So 0 plus 1 is 1. This column remains unchanged. And these columns remain unchanged. OK, now then, the number 4, well, that's 3 plus 1. So I add 1 to this column, and it has to carry. So we get a 0, which means I add 1 to this column, and again it has to carry. So I get another 0, and I carry into this column. And that is unchanged again. That is the number 4. OK, let's rattle through a few more. I'm going to write down the number 6, which is 0, 1, 1, 0. The number 7, 0, 1, 1, 1. The number 15, 1, 1, 1, 1. And then we get to the number 16, and we have a problem. OK, because I'm going to add 1 to this column, which means it's got to carry, which means I have 1 to this column, it has to carry. I have 1 to this column, it carries. I have 1 to this column, and so it carries. We've run out of space. I don't have another line to add a number to. Because what I want to do is put 1 here. But that, as far as the computer is concerned, this simply doesn't exist. So what's happened? We've wrapped back to where we started from. So we've hit a dead end. And we can only count to 15 using a 4-bit number. Now what I want to do is take this back to the Pac-Man problem. Okay? So Pac-Man had a microprocessor which was an 8-bit microprocessor, not a 4-bit microprocessor. And what that means is that if we want to represent the number 0, we need 8 zeros. 1, 2, 3, 4. 1, 2, 3, 4. Okay? Let's do it again. The number 1. What about the number 2? I'm going to be drawing a lot here, but OK. I'm going to do the number 8. Now let's skip up just a few more to what would be the number 253. OK, so we're getting close to the end here. 1, 0, 1. OK, the number 254. The number 255, and we've come back to a point where we reach a familiar problem. If I want to count to 256, here we go, I'm going to add 1 to 255. So it carries here, it carries here, it carries here, and here, and again it carries here, 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 and here, and I want to put 1 here, but the computer, Pac-Man, simply doesn't have a number big enough to store that value, and we're scuppered. Okay, so that's it. That is why 8-bit computers can only count to the number 255. And as a child, I was fascinated by this, absolutely fascinated. But it's taken me 15 years to get to the point where I can explain it to you.